Hi guys, I hope you're okay. This is the 7th video and I'm doing question 9 from the 2022 IEP Mathematics Paper 1 examination. Uh, just know that there are other questions that have been answered before this one, and there will be 3 more questions answered after this one. Just click the link on the description below. It will take you to the playlist with the full memorandum. You can download the question paper, answer the questions with me. If there are things you're not sure about, please do not hesitate to write on the comment section. Thank you. Okay, let's start. In the diagram below, we have the equation of a line w of x and t of x, and these two lines are the axes of symmetry of the given graph of h. Okay, E is a point that lies on H, and ABCD is a rectangle with AD on the x-axis. Okay, please note that, guys, the axes of symmetry, they intersect one another whenever the asymptotes intersect one another. So if I can find the point of intersection of the axis of symmetry, that means I'll be able to find the values of Q and P. Are you together? So how can I find the point of intersection? In the point of intersection, I know that my two graphs, WT and T, W of x and T of x, are equal, no? So I simply have negative x plus 6 is equal to x minus 4. Then I'll have negative 2x is equal to negative 10. Then x is equal to 5. Right, together. After finding 5, I must just go and find the corresponding y value. I can simply say, therefore, w of 5 will simply be equal to negative 5 plus 6, which is just 1. So I now know that the x value is 5 and the y value is 1. Are we together? So now I do know the values of a and p. All I need to do is to find the value of a. Since I know the values of a and p, I know that my equation will be like a is equal to a all over x minus 5 plus 1. All I need to do is to find a, but I do have an extra point on the graph of h, which is point E. The coordinates of E are 9 and 2. I know that the y value is 2 if and only if the x value is 9. There's a plus 1 there. If I take the 1 to the other side, I'll have 2 minus 1. I'll be left with 1. I'll have a divided by 9 minus 5, which is just 4. So the value of a is equal to 4. So therefore my equation of h of x, I have 4 all over x minus 5 plus 1. So this is my equation of x. The value of a is 4, the value of p is positive 5, and the value of q is positive 1. Okay, and then now I'm supposed to determine the area of the rectangle. The area of the rectangle, okay, if I can find the coordinates of a and d, I'll be able to find the base of my rectangle. And then if I can find the coordinates of c, the y value at c will tell me about the height of my rectangle, right? Okay, let me erase here, guys, just to create some room for me to write. As I'm erasing, I hope you are subscribing. So h of x is equal to 4 over x minus 5 plus 1. This was the graph, ne? Let me erase there. Okay, now let's answer the second question. Let's use a black ink. For the second question, let's erase here. and work with a clean picture. How can I get the coordinates of A? I can find the coordinates of A by making the graph of H to be equal to 0. Why am I doing that? Because A is at the x-axis of the graph of H. So I can simply say y is 0. I'll have 4 over x minus 5 plus 1. Take the 1 to the other side. I'll have negative 1 is equal to 4x minus 5. And multiply both sides by the LCD. Negative x plus 5 is equal to 4. Then negative x is equal to negative 1. Then x is 1. Okay, I now know that the coordinates of A, 1 and 0. Okay, what else can I do? I believe I can find the coordinates of C. C is the point of intersection between the graph of T and the graph of H, right? And T is equal to x minus 4. Whenever two curves intersect one another, you just have to equate them. T is equal to h of x. T is x minus 4. And then h of x is 4 over x minus 5 plus 1. I have minus 5 then. If I take the 1 to the other side, I will have x minus 5 is equal to 4 over x minus 5. Together, multiply both sides by the LCD. I will have x minus 5 times x minus 5 is equal to 4. The left hand side can be simply written as x minus 5 all squared is equal to 4, right? I can find the square root on both sides. Then x minus 5 is equal to 4. X minus 5 is equal to plus or minus 2, right? So I'll simply say x minus 5 is equal to negative 2, or x minus 5 is equal to positive 2. So x is equal to 7, and this side x is equal to negative 3. So this one, is it equal to negative 3? No. It's not equal to negative 3. It's equal to positive 3. Because I'll have negative 2 plus 5. Okay. So it simply means that the 3 is in here and the 7 is there. Né? So it simply means I know, since ABCD is a rectangle, it simply means that line CD is a vertical line. And if ever x is 7 at this point, it simply means the x value at D is also 7. Are we together? So all I need to do now is to find the corresponding y value. I'll just use the graph of T. T of 7 is equal to 7 minus 4. This will give me 3. So the coordinates of C, I simply have 7 and 3. Okay, so the distance of AD is 6 units. The distance of DC is 3 units. The area of a rectangle is length times height. That's 6 times 3, simply 18 square units. So the area of ABCD is simply 6 multiplied by 3, which is just 18 unit squared. That's how, guys, we would have tackled the question. Okay, now let's move to B. Now we are told that on the same set, on the set of x's below, sketch the graph of log 2x, and x is less or equal to 4. Okay, for this graph, I know that it will have an x-intercept at x is equal to 1. So it will go like this. Excuse my drawing. It will end here because they said x should be less than 4. Ne? Yes, it should be less than 4, but it's greater than 0 at the same time. So that's how my graph should look like. Obviously, yours, guys, will be more beautiful, more aesthetic than mine. Okay, and then on the same system of x's, okay, let's indicate this is g of x, which is equal to log 2x. In the same system of x's, I must draw the inverse of the graph. Okay, so the inverse of the graph, if my graph is log 2, okay, let's do this. What do I have more space? I have more space here. G of x, excuse me, g of x is equal to the log of x base 2, right? For me to find the inverse of the graph, the inverse only happens in this line, y is equal to x. All I need to do is to just substitute. I'll have x here and I'll have log y base 2. For me to solve for y, I just need to remove the logarithm. How can I remove the logarithm? By taking 2 and making it the base on the other side, and then x will be the exponent. So y will be 2 to the power x. It simply means that the inverse of g of x is equal to 2 to the x. So remember that, guys, the relationship between the inverse function and the original function. If you are given the domain of the original function, that domain will be the range of the inverse function. Are we together? So it simply means that the range of my inverse function, I can simply say that y has to be less or equal to 4. Are we together? So whenever I draw my inverse function, let me draw it in blue. It will be like that. Are we together? And it's not supposed to surpass the 0.24. The y value, it's not supposed to be above 4 in terms of y. Okay, now I'm supposed to write the domain of the graph of g of x. The domain, remember, that is my I must just check where is my graph available whenever I scan it horizontally. My graph is available whenever x is less than 2. Whenever x is less than 2, when x is less or equal to 2, or if you want to, can say when x is an element of negative infinity to positive 2. Okay, and then now we are being asked for which values of x will the inverse of x multiplied by the gradient of x all over the graph of g of x be less than 0. Okay, the derivative of g of x, my graph of g of x is forever positive. Are you together? In this case, guys, you have 3 things which are regarded as one term, ne? Yes, they are 2 of them are multiplying at the top and 1 of them is dividing, and the answer is less than 0 according to this thing, ne? It simply means that 2 of them have the same sign and 1 of them has a different sign. Are you together? However, they were just trying to trick us here. The derivative of g of x, this graph is forever positive, is forever increasing rather, which simply means that the derivative it will be always greater, or it will be always greater than 0 for x element of 0 to 4. Are you together? If the graph was not restricted, I would have just said the derivative will forever be greater than 0 for x element of real numbers. Are you together? But since it is restricted, I need to say the derivative will be always positive in this interval. Are you together? So since I know that g prime of x will forever be positive, I can just simply focus on the inverse and the original function. being less or equal to 0. I'm looking for the values of x whereby the two graphs have different signs, which simply means that the values of x whereby one graph is above the x-axis while the other is below the x-axis at the same time. Are you together? Okay, if I can check, if we can all check the when x is between 0 and 1 in this space over here, the red graph is below the x-axis and the blue graph is above the x-axis. So we can conclude that when x is between 0 and 1, our graphs have different signs. So the answer to that question, simply say that when x is between 0 and 1, when x is between 0 and 1, and I think when x is between 0 and 1, like this, that's the final solution of this question. I really hope that, guys, the video helped you out. Just stay tuned, guys, more videos are coming.